Hey guys, this is Cody with Hiline Academy, and today what we're going to talk about are the three pieces of information that we need to put any transformer or transformer bank into service. Coming at you. Alright guys, so I have a transformer hooked up phase to neutral. So you see the left bushing, my H1 bushing right here, it's going up to the cutout, it's going up to a phase, right? My H2 bushing on the right is going to the pole ground, which is then going down and it's tied into my circuit neutral. So my secondary side is just a regular 120, 240 single phase delta service. That's all it is, just feeding regular residential homes. So how did I get there? How did I come to the conclusion that I needed to make a phase to neutral connection on my primary side and a single phase delta connection on my secondary side? Well, it comes down to those three pieces of information: circuit voltage, the nameplate information, and the customer's voltage needs. Between those three pieces of information, we can determine both a primary hookup, wire delta, and a secondary hookup, wire delta. Let's get into it. All right, guys, so here we are. We've got our three pieces of information. We've got our circuit voltage, made up of the phase-to-phase potential of that circuit and the type of circuit that it is, whether it be a Y, a grounded Y, where the neutral is bonded to ground potential, or a delta. Next, we have our nameplate information, made up of our primary input, meaning what does the transformer need in voltage, and the secondary output, meaning if you give it whatever it needs, it's going to output whatever the number is on the secondary output. And finally, the customer voltage needs. So there's different ways they can tell you this information. For example, here we've got 120, 240, single phase, 3-wire, 120, 240, 3-phase, 4-wire, 4 wires meaning 3 phases and a neutral, and 277, 480, 3-phase, 4-wire. So what we're going to do now, guys, is we're going to break down each one of these categories, determine how we get that information, what it means, and how to determine the hookup. It's actually pretty dang easy. Stick with me. All right, guys, so the first thing that we're going to talk about is circuit voltage. And what I mean by circuit voltage is the phase-to-phase potential of that circuit and the type of circuit it is, whether it be a Y, a grounded Y, or a delta. And now what we're going to do is I'm going to break down what exactly it means to be a Y circuit and a delta circuit, and we're going to talk about where those voltages come from on that circuit. And the reason we're doing that, guys, is that so we can know what is available to us in terms of voltage when we go to hook up a transformer. All right, guys, so now we're going to talk about circuit voltage. And what I'm talking about when I talk about circuit voltage is the phase-to-phase potential of that circuit and the type of circuit it is. A Y, a grounded Y, where the neutral is bonded to ground potential, or a delta. All right, guys, so the first circuit that we're going to talk about, I'm going to say this circuit is a 12470 Y circuit. So 12470 Y. So what that consists of are 3 phases and a neutral. So I've got phase, phase, and phase, right? So from phase to phase, my phase-to-phase potential is 12470, right? My phase to neutral potential on this circuit is 7200. But we don't say that. We don't even worry about saying that. The only thing that we say is the phase-to-phase potential and the type of circuit that it is. In a Y circuit, it's just assumed. You don't even have to say it. It's just assumed that the phase to neutral voltage is 7200 volts. You just don't have to do it. So what we're looking at here are two different voltages to work with, right? We've got 12,470 phase to phase, and then phase to neutral, right? Phase to neutral, we've got 7,200. And guys, in a later video, we're going to break down exactly how you figure all this stuff out and why these voltages are what they are. There's a really easy mathematical formula that we use to explain all of this, but it really just comes down to angles and distance. If I had a 7,200 inch line, a 7,200 inch line, and a 7,200 inch line, and they were in this configuration or a Y configuration, separated by 120 degrees, right? So 120 degrees, 120 degree angle, 120 degree angle right here. 360 degrees cut in three pieces, right? 120 degrees. So when you have three lines 7,200 inches long, 120 degrees apart from each other, all three of them, these outside points are going to be, guess what? 12,470 inches long. That's would be the separation between these 2 points out here. Well, excuse me, these 3 points out here. 12,470 inches all the way around. And we'll get into that later. So in a Y circuit, I have two different voltages that I can work with. I've got both a phase-to-phase voltage, obviously, which in this case is 12,470 volts. And I've got a phase to neutral voltage, which in this case is 7,200 volts. So in a Y circuit, I've got two different voltages I have to work with. Phase to phase, 12,470 volts. Phase to neutral, 7,200 volts. Okay, so now let's look at a delta circuit. And just for number's sake, let's use the same 12,470 volts, but this time it's a delta circuit. So what that would look like would be, again, three lines. In this case, these three lines are going to be 12,470 inches long, and they're put together in a delta configuration, or just a triangle. So 12,470 inches, or volts, from here to here, 12,470 inches from here to here, and 12,470 inches from here to here. So phase to phase to phase, we've got 12,470 volts. So something interesting about these circuits, about delta circuits, are we do not have a neutral on a primary delta circuit. And it's going to be very obvious as we go later on through this process, so once you guys get dialed in on vectoring and all that, it becomes very obvious why we don't have neutrals on primary delta circuits. So the only potential that we have to work with in a delta circuit on the primary side is a phase-to-phase potential. That's it. And in this case, that phase-to-phase potential is 12,470 volts. All right, guys, so the next thing we're going to talk about is the nameplate information. And specifically, there's a lot of information on a nameplate, like a lot. But really, the only things that we're really concerned with in terms of making the connection is the primary input and the secondary output. So they can give you that information in different ways. So when you're looking on a nameplate, you're going to look for the primary input. So it's going to say primary, and then it'll say something like, for example, sometimes it'll give you two voltages, like 7,200 / 12,470 Y. It'll tell you like that. And what's really important to know about this information and how it gives it to you, this does not tell you how to hook it up Y or delta. There are some specifics on one of the types of nameplates that it is specific to the type of circuit it has to go on and how it has to be hooked up. But in this specific transformer right here, all this is telling you is that I need 7,200 volts. So when a transformer nameplate gives you two voltages like this, it's always going to be the smaller number. That's the one that you're going to want to put into that transformer. Another piece of information that this transformer is giving us, when it gives us the information like this, phase to neutral / phase-to-phase voltage, Y, what it's actually telling you is that this transformer has two insulated primary bushings, just like this one right here. So H1, H2, they're both insulated and on top of the transformer. So another way that nameplates will tell you what the primary input needs to be, sometimes they'll just give you one straight up number. Sometimes they'll just say 7200 volts. So if it just says 7200 volts, that's just what it is. It just needs that voltage. And this one, this type of nameplate, will also go on a transformer that has two insulated primary bushings. So this transformer, you can give it 7200 volts, whether that be either a phase-to-phase connection, they're both insulated, so we're good to go there, or a phase-to-neutral connection, right? So we can throw a phase in one of them and a neutral in the other. And finally, the last one that you're really going to see in terms of single-phase transformers in the field is you're going to see this one. 12470 grounded Y / 7200. And again, when they give you two voltages, a big one and a small one, the primary input requirements are this right here. They're always going to be the smaller number, always, regardless. If they're up here on the left, 7200 volts. If it's down here, it's on the right this time, 7200 volts. It's always going to be the smaller number. And this transformer specifically, when it tells you the information like this, 12470 grounded Y / 7200, it's telling us something else. It's telling us that we need 7200 volts running through that primary coil. And the second thing that it's telling us is this transformer specifically has to go on a grounded Y circuit. And the reason for that, it does not have two insulated primary bushings. What this one actually has, it will have one insulated primary bushing. So imagine this one isn't there, right? So we've got a coil that's attached to this that goes down, wraps around our core of our transformer, and rather than the other end coming out and going to an insulated bushing, it actually comes to the side of the can in a pot lug like this, but they're on the side over here. So this would be H1, the pot lug over here would be H2. So the pot lug, see how it's bonded to case right here? What they're telling us when they tell us grounded Y, it has to go on a grounded Y circuit. What they're telling us is that since the neutral connection will be touching the case, they want the neutral to be grounded so that the case is grounded for safety. So this is really the only one that's very specific in terms of how they want it hooked up and what type of circuit they want it to go on. So to recap some of the stuff that we've gone over in terms of nameplates, there's three different ways they're going to tell us the information that we need. They're going to tell us either like this, 7200 / 12470 Y, in which case it's always going to be the smaller number. 7200 volts is what the transformer needs. It's going to give us just one number, 7200 volts, in which case it just needs 7200 volts. And the last one is like this, 12470 grounded Y / 7200, in which case, again, it's always the smaller number, right? 7200 volts is what the transformer needs. But this transformer specifically needs to be hooked up on a grounded Y circuit where the neutral is bonded to ground potential. All right, guys, so the next thing we're going to talk about is the customer's voltage needs. Now, what we're saying here, the customer's going to come to you. It's going to be on your print. It's going to be on something telling you, hey, the customer's saying, I need 120/240 single phase 3-wire. So those 3 wires made up of 2 phases and a neutral, 120/240 single phase 3-wire. Another way they could tell you, they might say, I need 120/240 3-phase 4-wire. 4 wires being 3 phases and a neutral. The 4th wire is always the neutral. Or maybe it says 277/480 3-phase 4-wire. Again, being 3 phases and a neutral, right? So what in the world does all that mean, and how do we use this information to determine a secondary hookup? So what we do is there's a couple funny little rules. And I don't know if any of you guys have ever heard this, but the term delta divide. Delta divide. So in terms of secondary hookup, this right here, the customer's voltage needs, this right here is going to determine how you hook up that secondary connection, either Y or delta. So a really quick, easy way to look at my customer's voltage needs and determine secondary hookup is this simple little rule. Ready? Delta divides. Delta divides. And what I mean by that is if these numbers divide evenly into each other, meaning 120 will divide evenly into 240, it's going to be a delta. And if it does not, for example, like 277 and 480, well, those two numbers do not divide evenly into each other. So these would be a Y. So again, delta divide. 120 divides evenly into 240. If it does, it's a delta. Let's say it's a 240, 480, three-phase, four-wire. 240 divides evenly into 480. Therefore, this connection would be a delta connection. 277, 480. That does not divide evenly into each other. Therefore, it's going to be a Y connection. 120, 240, three-phase, four-wire. Obviously divides evenly. It's going to be a delta connection. 120, 240, single-phase, three-wire. Single-phase, we think, oh, well, whatever, you know, delta, single-phase, three-wire. We only think of three-phase power ever being delta. Single-phase house service is a delta connected service, believe it or not. So 120 divides evenly into 240, delta hookup. Not three-phase, but it is single-phase delta. And finally, 120, 208, three-phase, four-wire. And guys, I apologize. I know there's a ton of different voltages around the world. Europe uses some pretty crazy high stuff, so there's a ton of them out there, but the same rules apply. Delta divide. If your voltages divide evenly into each other, it's going to be a delta. If they don't, it's going to be a Y. So guys, just to recap this real quick, customer needs, that determines the hookup, not the nameplate of the transformer. The other little thing, remember, delta divides. Delta divides. Okie doke. So 120, 240. Delta, right? Delta divides. 120 goes evenly into 240. That's a delta hookup. 120, 208. That does not go evenly into 208. Therefore, it's a Y. Let me see, 277, 480. That does not divide evenly into 480. Therefore, it's a Y. 240, 480. 240, 480. 240 divides evenly into 480. Therefore, it's a delta. So now the last thing that we're going to do is we're going to put all three pieces of information together: circuit voltage, nameplate information, and customer needs. We're going to put them all together and determine both primary hookup and secondary hookup. All right, guys, so what I've got up here, it's kind of a fun little game. I don't know how fun it is, but it helps us learn about transformers. So if you guys are apprenticeship instructors, if you guys have apprentices on your crew, this is a really cool little drill you can draw up for them and just give them problems maybe at lunchtime or whatever. So what I've got over here, I've got circuit voltage, I've got nameplate, and I've got my customer needs over here, right? And in between them, I've got a wire delta, little symbols up there. So what I'm going to do, guys, is I'm going to draw up a bunch of circuit voltages here. So let's say we've got 12,470 Y, okay? And then maybe my next one, let's do 4,800 delta. And then let's say we've got 12,000 Y. And then let's say, okay, our next one's going to be what? I don't even know. 4160 Y. So we've got a few circuit voltages up there. So nameplate, right? Nameplate information, let's say this one is our favorite 7200 12470 Y 120 240 output, right? My customer needs 120 240, let's say single phase 3-wire. Okie doke. So in looking at this one, we're going to say, okay, 12470. I know my transformer needs 7200 volts. So what I'm going to do is I'm going to use my primary input requirements of this transformer along with my circuit voltage to determine the hookup. And here's a quick, easy little hack, okay? What you need to do is ask yourself, where does 7200 volts live on this circuit? Is it phase to phase or phase to neutral? We know that 12470 is the phase to phase potential, right? Because that's how we name our circuit. Phase to phase potential, type of circuit. So we know that 12470 is the phase to phase potential. And in a 12470 circuit, 7200 volts lives phase to neutral, right? Phase to neutral is going to be a Y hookup. So an even quick, easier little hack is this. Check this out. If this number matches, if it's the same as this number, it will be a delta. I'll say it again. If this number is the same as this number, the hookup will be a delta. If it is not, which is what we have here, this is not the same as this, it's going to be a Y. All right, so moving on, the next thing we have to look at is our customer needs. So our customer needs determine the hookup on the secondary side, not the nameplate. Customer needs determine my hookup on my secondary side. So what's the rule? Remember, delta divides. Delta divides. So 120 240 single phase 3-wire, that's going to be a delta, isn't it? 120 divides evenly into 240, it's going to be a delta. Now the next thing we need to ask is, can I fulfill my customer needs with this transformer? If the answer is yes, go ahead and write it in. We've got a delta. So the next one, we've got 4800 delta. So my circuit's a 4800 delta, phase to phase to phase, 4800 volts. So my nameplate, let's say it says 4800. Let's say, I don't even know, 277. So 277 volt output. So primary input, 4800, 277 volt output. My customer needs, let's say they are 277, 480, 3-phase this time, 4-wire. So there's 3 transformers here, right? This is the nameplate for all 3 of them. So again, remember the little hack. If this number matches this number, it's going to be a delta, right? So 4800 volt input, 4800 phase to phase, those 2 numbers match, delta hookup. Secondary side, right? We've got to determine our secondary hookup. Customer needs determines secondary hookup, not the nameplate. So customer needs determine. So the little rule that we use, the little hack, delta divide, right? So does delta divide? Does this divide evenly into each other? 277, does that divide evenly into 480? Obviously not. Therefore, it's not a delta. It is going to be a Y. Next one, we've got 12,000 Y. So let's say, okay, 12,000 Y. Let's say my transformer nameplate just says 12,000. Let's say it says 12,000, 120 output. So 120 volt output. So my nameplate, let's say it says 120, or excuse me, my customer needs, let's say it's 120, 208, 3-phase, 4-wire, okay? So moving over here, starting in my primary, does this number match that number? If the answer is yes, we know that it's going to be a delta hookup. Delta hookup, right? This is my phase-to-phase voltage on that circuit. My transformer needs the same number. Therefore, the only way to hook it up is phase-to-phase or delta. Secondary. So customer needs 120, 208, 3-phase 4-wire. My secondary output 120. So delta divide. Does 120 divide evenly into 208? No, it does not. It's going to be a Y hookup. Next question, can I fulfill my customer needs with these transformers, right? Again, there's going to be 3 transformers. Here, this is the nameplate for all 3 of them. So can I fulfill this voltage with 3 of these? And the answer is yes. Yes, it will be a Y hookup. So 120 inches, 120 inches, 120 inches, phase to phase to phase, 208 inches, right? 120 inches, 120 inches, 120 inches, phase to phase, that distance right there is going to be 208, right? Right on. So in the last one, so 4160Y, let's say nameplate just says 2400. Let's say it just says 2400, 120, 240. Customer needs, let's say it's 120, 240, 3-phase, 4-wire. So again, 3 transformers here. So 4160, 2400. Do these numbers match? If they don't match, it's going to be a Y. Where does 2400 volts live on this circuit? It's going to be phase to neutral, right? So this is going to be a Y primary hookup. Secondary hookup, delta divide. Remember, customer needs determines secondary hookup. 120, 240 divide evenly into each other, right? So delta divide, it's going to be a delta. The next question, can I fulfill my customer needs with these 3 transformers? If the answer is yes, go ahead and write it in. And lastly, I'm going to throw this one other one in here. This one's kind of neat. So let's say 7200 Y circuit, right? Let's say my nameplate on my transformer, it's going to be this transformer up here. Same exact transformer. 12470Y, I don't know, 12240. So same exact transformer that was up here, still needs 7200 volts, right? But now, how am I going to hook this transformer up on this circuit? So does that number match that number? If the answer is yes, then we know it's going to be a delta hookup, right? See up here, same transformer, different circuit. On this circuit, this transformer had to be hooked up Y because of where 7200 volts was on this circuit. On this circuit down here, 7200 volts lives phase to phase on this circuit, right? Therefore, it has to be hooked up delta. Customer needs 120, 240. We're just going to do that one again. 120, 240, 3-phase 4-wire. So remember, customer needs determines secondary hookup. So delta divide, 120 goes evenly into 240. Answer is yes. Can I fulfill my customer needs with those transformers? If the answer is yes, fill it in. So guys, just to recap what we've gone over today, in order to hook up any transformer or transformer bank, we need 3 pieces of information, right? Circuit voltage that you're working on, nameplate information, and the customer's voltage needs. So things to remember about circuit voltage, it's always the phase-to-phase potential of the circuit we're working on and the type of circuit it is, whether it be a Y, a grounded Y, or a delta. The second thing is the nameplate information. Things to always remember about that, we need the primary input and the secondary output of that transformer. And lastly, we need the customer's voltage needs, right? Things to remember about customer needs are, customer needs always determines my secondary hookup, either Y or delta. The second thing is that delta divides, right? So if I look at my customer needs and my voltages divide evenly into each other, it's going to be a delta hookup. If it doesn't, it's going to be a Y hookup. And guys, please let me know if you learned anything from this video. If you have any questions or comments, please leave them down below. And like always, don't forget to hit that like button and the bell notification icon. That way, every single time I come out with new content, you'll be the first one to know. And thanks for your time. We'll see you.